Today I wanted to talk about green infrastructure and the support that it can offer to urban biodiversity. I wanted to explore this topic because I'm really fascinated with the blending of natural and built environments. I thought back to my previous experiences and I realized that often the mention of biodiversity is kind of the same generic, just support biodiversity. So, for example, if a green design feature is talking about the goals it's going to achieve, it's going to do X, Y, and Z and support biodiversity, the dynamics of exactly how it would accomplish X, Y, and Z are going to be really well laid out, but there's going to be little or no elaboration on the biodiversity aspect. So, this gives you kind of the appearance that just being green space ensured that they're meeting that goal. And this begs the question, is that true? Are all urban green spaces created equally? Is being a green space within an urban environment enough to support biodiversity? So I wanted to do a brief overview of some of the core concepts and then explore some of the information that I found. So first, biodiversity. I have a few standard definitions on the screen, but simply put, biodiversity is the variation within and between ecosystems and then within and between species. So that diversity offers resilience and helps ensure that ecosystems, species, and populations all have the ability to adapt to changing environmental conditions. That genetic diversity is where you're going to get evolutionary processes and adaptations from. So, from an anthropocentric viewpoint, retaining biodiversity is key to retaining many ecosystem services, and also it's key to the future potential of discovery of biomimicry and medicinal qualities, things that we might lose out on the chance of benefiting from if those species go extinct before we're even aware that they exist. And currently, massive extinctions are a pressing concern, and biodiversity is one of the highest risk areas within the planetary boundaries model. Anthropogenic actions that are leading to loss of habitat, introduction of invasive species, and climate changes that species might not be able to adapt in time, all threaten biodiversity. So switching to an overview of biodiversity and green infrastructure, I haven't found a lot of research that explores these dynamics in the context I was looking for. However, what I did find I noticed is from the last several years, this seems to show a trend in research paying more attention to this area and focusing in on it more. I've also found a lot of papers that are focusing specifically on the biodiversity impacts of that green infrastructure has had on a single species, primarily like migratory birds. So this paper here, the contributions of constructive green infrastructure to biodiversity, is really interesting because it's discussing that research gap. As they put it, there's still a significant research gap with regard to the measured benefits of incorporating green space into city infrastructure for biodiversity. And they talk about how designs are implied to offer benefits of biodiversity, but usually with little quantifiable research and data to accompany those claims or apparently to guide those actions. And what they did was analyzed studies that were done in this 40-year period, and of those, only a handful had data that they could really analyze and look at the impacts of green infrastructure on biodiversity in that particular area. So what they found was biosoils and green roofs provided the biggest biodiversity boost over conventional methods. And that really makes sense because, what is a conventional method alternative to a biosoil or green roof? Just a plain clear zone on the side of a road and a plain roof. So, of course, once you add in those green infrastructure elements, you're going to have more biodiversity in that particular area. The other thing I thought was very interesting was there was not a significant effect on biodiversity, urban biodiversity, relative to conventional counterparts with wetland detention basins and urban gardens. I thought that was really interesting. And I kind of want to delve a little deeper into that because I was surprised to see that, and it makes me wonder why. If you have even if it's an artificially constructed wetland detention basin, if those are being done in a manner that mimics the natural wetland ecosystems, I'm surprised that it's not going to have more biodiversity than just a plain water retention basin. So I think that's something really interesting to look into further. Next, I'd like to go over a few examples of green infrastructure within urbanized areas. I thought this graphic was really interesting. It shows several different types of urbanized green infrastructure under categories based on kind of the level of human involvement. You have heavily maintained, managed, unmanaged, vacant lots, brownfields, remnants, etc. So I'm not going to go over all 8 of these in depth. Instead, I'm just going to focus on a few that I found research information about so far in relation to biodiversity support. So, starting with green roofs. These are the 2 most common types, extensive and intensive. So extensive green roofs, they have a thinner substrate and they're more homogeneous generally, and they do offer a poorer quality habitat, but their ecological benefit can be improved with the use of native plantings. However, they are more maintenance free, they're more economical, so they do tend to be able to cover a larger area, plus the thinner substrate means less volume of growing material, so it's more feasible for more buildings. With the intensive green roofs, they are a higher quality habitat, but it has a deeper substrate, and while that supports a wider range of plants, the growing medium that level of growing medium, isn't suitable for all buildings. So regarding green roofs and connectivity, the thought is that they can offer a stepping stone type connectivity to combat fragmentation, and some believe that they function more as an ecological trap though, which I'll go over in a few slides. And as a different research paper pointed out, intensive high quality habitats are less frequent, and extensive low quality habitats are more frequent but less useful. Therefore, even if they do form a bit of a stepping stone connectivity through urban areas, it's a very uneven patchwork of such, which can affect, the positive support of biodiversity. So what's something that was suggested instead, or like an alternative, is this idea of biodiverse or brown roofs, which I had heard of before but I thought was really interesting. So this third type is modeled after brownfields. They have a thinner substrate, just like the extensive green roofs, but they're not seeded or managed by humans. Ideally, the growing medium would be taken from an existing brownfield, complete with the vegetation, organisms, and seed bank that's already contained within that soil, and then deposited on the roof. So this offers a higher quality habitat, and it's more it's more accessible to a wider range of buildings because of the lower volume and material. Ideally, brown roofs also have a variety of abiotic factors such as like stone, crushed concrete, along with things like decayed logs and branches that are scattered throughout to mimic how a natural landscape would be, and that provides more microhabitats and nesting potential for a diverse range of species.
So this next slide has a assessment framework for evaluating green roofs. It was developed by the authors of this study after they identified an urgent need to examine biodiversity effects and develop a systematic way to evaluate the performance of green roofs and their impact on biodiversity. So they draw attention to the same lack of specifics in green building rating systems and other planning literature. For example, LEED mentions promoting biodiversity as part of the intent for the sustainable site credits, but it really doesn't go any further. So they honed in on that and created this assessment framework. This is the only one I found so far, but I'm hoping to find others, or maybe find information that could help inform the creation of others for green roofs and for bioswales, rain gardens, etc.
The next urban green space I wanted to go over is brownfields. These are typically abandoned spaces that were commercial or industrial complexes that have been passed over for redevelopment in favor of developing on previously undeveloped land. These are valuable ecological systems that occur within urban areas. They're often allowed to develop naturally. They tend to have highly diverse mixes of species due to the introduced species around them from the urban landscapes as well as the natural landscapes. So they have a bit of mix of native and exotic species. Brownfields that have poor nutrient loads actually tend to be very valuable because they limit the growth of fast-growing species that would quickly outcompete and dominate the landscape, pushing out other species like wildflowers. So by limiting their growth, it gives species like wildflowers a better chance to grow and serve as good habitat and attraction for pollinators like bees and butterflies. Rain gardens and bioswales. I did not find a lot of information regarding the biodiversity support found within these, other than the one research paper that I mentioned a few slides ago. However, I want to continue to look for frameworks to assess the biodiversity support qualities of these types of systems, or if I can't find those, continue to look for information that would help maybe inform the development of one. As I was looking for the answers to these questions of are all urban spaces equal, or do all urban green spaces have positive impacts on biodiversity support, I came across this concept that some urban green spaces actually serve as sink habitats and ecological traps. These next couple slides have a lot of definitions on them. I'll go over some of them briefly. So, species use cues to make decisions about things such as which habitat is best suited for them. Source habitats are good quality patches that have enough resources to support a higher birth rate than a mortality rate. Sink habitats are the opposite. They have poor quality and less resources, and that leads to more deaths than births. In severe situations, they are not able to support reproduction at all, merely the survival of an individual. Typically, an individual will avoid a sink habitat unless they're either outcompeted and forced into it, or something such as a change that makes it so that individual can no longer detect that it's, or that cannot detect that it's a sink habitat. An ecological trap occurs when those poor quality habitats represent the cues of a high quality habitat. The diagram to the right explains this. So in the situation where habitat 1 is a high quality and has cues A, B, and C, and the next habitat is medium quality. It has some cues, but not all. Therefore, habitat 1 is preferred. However, if a change comes along that makes habitat 1 lower quality, but it still has those cues A, B, and C, a species, an individual will continue to select it thinking it is the higher quality habitat, when in reality, the medium quality habitat, habitat 2, is now the better of the two options. However, it will be passed over and be what is considered a undervalued resource, and habitat 1 will become what is considered a severe trap, a sink habitat that has become more attractive and thus actively preferred by an individual over other more suitable habitats. A couple things I want to point out on this slide is the concept of urban avoiders, adapters, and exploiters. These species have varying levels of sensitivity to human impacted habitats. Along with this on this next side shows that not all species or individuals are getting caught up in traps. Not all of them are falling prey to this. So understanding the dynamics of these different concepts can help with developing a framework to assess urban green spaces and inform decisions about green design to make them as supportive to biodiversity as possible. There's a couple questions that I have right there that I think would be really interesting to explore further for a potential thesis topic. Such as what can we do as designers to ensure the green spaces we create are as productive, functional, and supportive to biodiversity as possible? How can we identify the potential details within those spaces that might make them ecological traps and correct them? So how does this happen? And by this I mean the lack of in-depth information surrounding biodiversity support and what it means to be supportive to biodiversity. So a research study that I found actually looked to explore the utilization of ecological information among urban planners, and what they did is poll planners in the Southwest U.S., asking them about their views on biodiversity conservation, the local factors that drove pursuance of biodiversity conservation measures, and what information those planners use to make their decisions regarding biodiversity conservation. So what they wanted to know is, the quotes I have up there from them is a planner's understanding of what counts as conserving biodiversity the same as an ecologist's understanding? Overall, what they found was apparently not. Their findings was that there is a major disconnect between ecologists and planners when it comes to biodiversity conservation. The majority of planners surveyed said they did not use ecological information, and they rarely used scientific information in their work, instead relying primarily on the work of their colleagues, other planners. This is despite a high percentage indicating that biodiversity is important to them. But what the researchers found is that the availability, relevance, and ease of understanding the scientific data was a major barrier to connecting planners to the research of ecologists. Often the research of ecologists was very specialized, and maybe it wasn't relevant to what the planners were looking for, or wasn't packaged in a way that was easily applicable and understandable by planners. Therefore, they were relying more on information from other planners rather than from ecologists.
So moving forward, I've already highlighted several key steps and questions going forward, and to kind of summarize those, it'd be the analysis of elements in urban green spaces that cause them to be considered ecological traps, continued research into those aspects and those dynamics, continuing looking for assessment frameworks that do exist and where they do not, creating those assessment frameworks for urban green spaces to ensure best possible support of urban diversity, or at least try to research information that could inform the assessment. And then ideally would be to package that assessment and guidance for using it in a format that would be easily accessible across disciplines. Something like, like the LEED guidance that they have, it makes it very easy. They have a very good format. So something like that I think could be a very interesting project, maybe a little bit beyond the scope of what we do. But thank you so much for listening and have a great day.